So, welcome San Diego Machine Learning. We're on Meetup. I assume if you're here, then you've already found us on Meetup, so I don't need to say too much about this. And then, all the events, and you get emails and stuff for the upcoming events. We do have a GitHub repo. And so actually we have two of them. So the book club repo, this lists all the different books that we've discussed. So it's got the current and the past ones. And if you take a look at the SQL page, it will have information on, link to the book, and then the meetups. And so, for example, for this week, I've got the notes, as well as I will be showing you a sample database file that the author created, and a Jupyter notebook for how you can write queries from inside Jupyter. Since this is San Diego Machine Learning, a lot of people may be familiar with Jupyter, but if you have access to other database systems, then you can also they have samples for those other systems as well. So all this different kind of information, we'll keep it updated here on the GitHub. So with that, let me just transition to the actual intro for today. So in terms of the book, you can see I've got the chapters listed here, and there's 22 chapters. And so right now, tentatively, if we keep going weekly, 2 chapters a week, in 12 weeks, we'll be able to cover the whole book. So we'll finish just before Thanksgiving. And as I said, the chapters are very short. The title is, SQL in 10 minutes a week. So I don't know if it's exactly 10 minutes, but yeah, they're not huge, beefy chapters. So I wanted to say a little bit more about the format. So this is really intended to be a community-focused project. And so one of the things we're going to do in this series is that we're going to have people volunteer each week to lead the discussion for that week. All right. So I put together a couple notes here in a Google Doc. Sometimes people like to create slides. And, I'll be here every week. Ryan will be here most weeks. So the intent isn't that the person who leads the discussion is supposed to be an expert or anything like that. It's just an opportunity to sort of mix things up for you guys to hear different voices, different ways of talking about things. I also think it's a really good opportunity for people to practice talking about technical subjects with other people. So whether it's kind of like a version of interview prep, or having a recording of you talking about something that you've prepared. And so, if we upload it to Ryan's YouTube, then you can point other people to, hey, here's me talking about, how to filter queries in SQL. So it's an opportunity for that. We've got a number of people who've already volunteered. And so I think I've got 7 people lined up, but there are a few spots towards the end of the book available. So I'm going to open up to you guys. You can email me, contact me via Meetup. You can email me. It's just my first name, last name, tedkey@gmail.com. If you're also interested in taking a week, and so I'll just do kind of first come, first served. I think there's like maybe 3-4 weeks left at the end if I hear from people. And so that's the format. And James, I'm sorry, I didn't ask you if you pronounce the T in your last name. Is it Colbert or Colbert?
Yeah, that's a subject of heated debate. I just say Colbert. It's just easier that way.
Okay, so James is awesome, and he volunteered. So next week, actually, he's going to be leading the discussion on chapters 2 and 3. I'll take us through just chapter 1 this week. And then, like I said, we'll have a series of people. So let me know if you're interested in taking a chapter. And like I said, I'll just kind of do first come, first serve. The chapters are pretty short, as I've mentioned, so I don't think it's terribly much work to prepare. In terms of the focus of this series, so I purposefully chose for this to be sort of a lighter focus. So I wanted this to be focused more on retrieving data and the different commands you need to know if you need to, filter it and join it with something else and things like that. The end of the book does cover basics about, hey, you also might need to know how to insert or, data to database or delete a row from the database. But this is really not intended to be like databases 101, right? This is meant to be a little bit more practical. So that's the focus of this. And there's tons and tons of resources. I picked this particular book because I felt it kind of matched what I was looking for in terms of it was really focused on writing queries and pulling data out, and less about let me teach you how databases work and stuff like that. If people are interested, at the end we could see we could actually continue the series and talk about some more things. I do think that naturally questions will arise, like why do it this way, or if there's a recommendation to do it this way instead of that way, they both work but one's faster, then sometimes it helps to understand how relational databases work. And so if that's the case, then we'll add color and it will naturally like weave a little bit of it in. But like I said, this is purposefully meant to kind of go faster for the people who just want to like brush up their SQL or learn SQL, learn how to be able to pull data out. It's meant to really focus on just that part. And so, like I said, we can see at the end if people are interested in diving deeper into how databases work. So let's see here. And then just a brief mention, so SDML has other events going on. So there's a Saturday book club, a little bit more advanced topic. We're talking about quantum computing. Ryan and I do this event sort of like office hours where we answer people's questions, talk about projects. Sometimes people are working on a particular Kaggle competition, or they're trying to learn a particular algorithm. We talk about that. So we also have a series that happens to be going right now where it's a series about rigorous foundations for statistics. That's going every other Thursday. So if you guys aren't SDML regulars, just wanted to kind of mention that. All right. So with all those preliminaries out of the way, let's actually talk about chapter 1 of the book, why SQL, and it's just got a few different basics in there. So what is a database? A database is some kind of container where you're storing data. Typically, when I think of databases, I'm referring to sort of persistent storage. So this is something that you're going to store on a disk and you don't have to worry about disappearing. Technically speaking, there are like in-memory databases, and there's for every rule, there's like exceptions. But generally speaking, we're talking about that. And then in particular, we're talking about relational database systems. If you're not familiar with that term, but it's a particular kind of database. And there were systems before relational databases, and especially now recently, there's a lot of other kinds of database systems. There's NoSQL. You may have heard the term NoSQL databases. So when we talk about, hey, data stored in like tables, rows, and columns, we're really talking about relational databases. And that's still the primary system that goes behind transactional systems. So if you go and you buy something on eBay or whatever, where that is recorded is likely going to be a relational database. Other aspects of it, like the catalog of products and comments and things like that, might be stored in some other kind of database. So in a relational database, we have tables, and tables are basically the book talks about like our different files, filing cabinet. So we're going to store a particular thing. We're going to store a list of customers. We're going to store a list of products. We're going to store orders. And you can think of them like grids, kind of like a spreadsheet. So we're going to have rows and columns. In each column, it'll have a name. And each column also in a relational database has a defined data type. So in an Excel spreadsheet, in one column, you can mix things. You can start putting numbers in the first few rows in a column. And then at some point you can just decide, hey, I'm just going to put, text in there, and I'm going to put hello. But mostly SQL databases, they're expecting you to be a little bit more rigorous. And so if you say the first column is an ID number, then it has to be all numbers. You can't just put hello in one of them. And if the second one is first name and it's up to 25 characters, then that's what you've told it you're going to store there. You can't put a 26 character name in there. You'll get an error message. Okay. And then I think most people, if you work in a technical area, you're familiar with the concept of a data type. But so if you define a certain column as having a number, having a date, having a string, these kinds of things, generally speaking, the database is going to enforce that you stick to that particular data type for that column. Rows are the basic unit of data in our database. So again, there are exceptions. If you read about newer database systems and ways people are organizing things for faster this or that or whatever, you're going to find exceptions. But in a traditional relational database, what we're going to have is we're going to have a row which contains all of the columns, even if some of the columns have zeros or blanks or whatever. That is going to be the basic chunk, the basic unit of storage in a relational database. So what we're going to do is we're going to be finding rows, and then we don't have to return everything in the row. We can return just portions of it. But basically, when we write these queries, that's what we're going to be doing, is we're going to be finding particular rows and finding particular columns in those rows. And then as we get more advanced, we're not just going to be looking at one table, but we may be looking at two tables. So we'll have a customer table and an order table, and we can find, for example, all the customers whose last name is Smith. And then we can actually link that, we can join it with the orders table and say, now show me all the orders for all the customers you found whose last name is Smith. And that's pretty much the gist of the type of SQL queries that we're going to write. All right, let me pause there. I feel like maybe I was talking a little bit fast. I don't know if it's the heat. Any comments, questions? How we doing? All right, sounds good. So then the last technical term in this first section of the chapter is this idea of the primary key. Okay, thanks. So the primary key is a unique ID for a particular row in a table. And the primary keys, are per table. So in the customer table, you have a primary key. And if the orders table has a primary key, then, those are completely separate. So what we want is we want every primary key to be unique in the customer table. So if Ryan has customer ID 3, then Maya cannot also have customer ID 3. She has to have a different customer ID. You can define whatever column you want to be the primary key. And technically, you can use whatever data types you want. You can use strings or things like that. What you will see is often it is some type of numeric data, like an integer, because those tend to be very fast for a computer to work with. So that's why you would typically have a customer ID that's something like 3, as opposed to a customer ID that's like the string XYZ 1, 2, 3. It's mentioned that you can have a multi-column primary key. So if I said, gosh, I don't know a good example, but well, this would be a terrible thing, but like if you did first name and last name as two separate columns in your table, and you wanted that to be your unique ID, then two people could have the same first name, and two different people could have the same last name, but nobody could have the combination of the same first name and last name. You would get an error message. So behind the scenes, when you have a primary key, basically the database system is using that key as the unique ID sort of to find, to I don't know, name whatever, that row. And so if you're returning a bunch of rows, then basically it knows the primary keys for all the rows that it's returning. And that's the way it's keeping track of things. And so you could certainly imagine in any, real world scenario, if you are a student and you have a student ID, there's not going to be two people with the same student ID. And if you go to the registrar's office, they ask you what your student ID is, and they can pull up all the information about you, from that. And that's sort of their their way of accessing, all the information. So it's sort of the same way in a table. Because this is this unique ID, it's pretty rare that you see that primary keys are modified. Okay, they might occasionally be deleted. You could say, well, customers who haven't ordered from us in the last 5 years, we're going to delete them all. Okay, but it's pretty rare that you would see that they get modified. All right, that's the database basics section. Any comments or questions? All right. So then I think you guys, generally are familiar with what SQL is. So let me just kind of go quickly. So SQL, stands for Structured Query Language. That's where the S and SQL originally came from. And one thing I just want to point out, I don't think the book mentioned this, but SQL is a declarative language. This is sort of the technical thing that we say about SQL. So when you program in Python, you're generally telling the computer, I want you to do this, and then I want you to do that, and then I want you to do that. Okay, and so you're telling it what things you want it to do. And so if you're going to store something, and then you're going to read it, you're going to multiply by 2, and then save it again, you're telling the computer like the steps that you want it to follow. One thing just to note, I don't think this is a big deal, but just so you guys understand that SQL has a different vibe to it because you're telling it, this is the data I want. I'm not going to tell you how to get it. Okay, I'm just simply going to tell you sort of the things I'm interested in, the things I'm not interested, and you go figure out however you're going to do it under the hood to go and bring back that data to me. Okay, so if you haven't ever worked with a declarative language, it's just a different vibe, because again, you're never going to have sort of steps. You're never going to have, well, I shouldn't say never, but in SQL, the way of operating is you don't have do this, do that third. It's really just all about, here are the properties of the information I want. Now please go and get it. All right, so it looks like the question in the chat got answered. So yes, so it is, I would say 90+% of the time, the primary key is only going to be in a single column, and it'll be something numeric. It won't be strings. But again, for every rule, there's an exception, and you can have multi-column IDs. I think like a simple example is I work in medical, and so when you have a medical thing, you have this claim. We have claim IDs. Well, claims have line numbers, and so it's reasonable to have a table where you say there's a unique claim ID, but all the lines are basically claim ID, comma, what line number. And so we have claim ID, 5678, line 1, claim 5678, line 2, claim 5678, line 3. And so I could have 2 columns in my table, one that's claim ID and one that's line number. And the combination of the two always has to be unique, but it's not a single column primary key. All right, so I was saying SQL's declarative language, so you're not going to tell it the steps. And so sometimes for something tricky, I actually end up bringing it up into individual steps. I end up doing it sequentially if it's just a very large complex thing, and sometimes that's easier. But as for those of you who are really new to SQL, just know that like you can't sort of, there isn't a way to sort of say, hey, do this and then do that. The other thing that's related to it is that there's this theory behind databases and stuff, but basically it's intended to be in terms of like set operations. So you can say like, I want you to look at all the rows in the customer table and find the ones where the last name is Smith. Okay, again, you're not telling it how to look for them, and you're not telling it doesn't know how many they're going to be. You're just sort of saying this is what I want. And so it's essentially there's no sequencing to it. So if you say, okay, I want the customers whose last name is Smith and who were born in September, again, it could do it in either way. It could find all the people born in September and then see which of those are named Smith, or it could see all the people who are named Smith and then find out who's born, or if it somehow has a way to do the both simultaneously, it can do that. There isn't really this idea of do this, then do that. You're just sort of telling it like, the criteria for the subset of what you want. And there's slight differences between every database. I've spent most of my life with Microsoft SQL Server, but you can use Oracle, you can use MySQL, SQLite, and they all work pretty well. So the core that we're going to learn will be roughly a core set that you can use the same syntax on any system. All right, let me see. So then the last section, the author talks about trying it yourself. I think the going will be pretty easy at the beginning, but again, when we get to slightly more complex stuff with joins and things like that, you probably, really do want to be playing around and practicing in order to make sure you really understand it, but also like certainly it helps me for things to sink in. So the structure is each chapter has a few challenge questions at the end, and in the GitHub, we have a link to where the author has answers to all the challenge questions. So you can do that. There's also a gazillion resources online. One of the things I didn't mention is most of the things online for teaching you SQL, they have the ability for you to run SQL right there on the web page. So that's really awesome. So I linked 2 here that I like because they don't have a whole lot of ads and they seem to have like pretty good technical content, SQL Zoo and SQL Bolt, but there's a gazillion, W3 Schools and Data Camp and Free Code Camp, and there's a whole bunch of them. And so I haven't tried them all, but the cool thing is that most of them, in addition to having whatever lessons and content, you can actually type SQL and you can see what happens when you run it. You won't necessarily have the same data that's in this book if you go somewhere else. All right, so let's see here. There's some stuff so let me go to the easy question. So you definitely can use Postgres to play because the SQL we're learning is very standard. It'll work on Postgres too. I don't remember if the author actually had Postgres sample scripts for setting up all the data. So it's down here. Oh, yep, he does. So good. So you're all set. If you follow this link, there's going to be a script to create all the tables and then a script to insert sample rows in all them. And then if you run the queries that are in the book, you'll get the exact same answers that everybody else has. There was a question about like indexing. So indexing when it comes to relational databases deals with performance. So I'm not going to necessarily spend too much time today, talking about that. But the main thing is that if you are retrieving customer ID 12345, then you're saying I want a very specific single row, and the database, should be able to do it pretty quickly. But in terms of the SQL you're writing, you're just simply giving it sort of instructions saying, this is the criteria of what I want. And it can go about using index or not using index, however it wants to go and find that piece of data. Okay. And so all the SQL that we're writing, that's one of the things that people need to learn, is that you don't ever get to say, do this, then do that. You just simply have to say, this is the criteria for everything that I want, and then the system will figure all of that out. Does that? So I'm looking specifically at your question, Maya. Does that answer your question?
I thought that I just don't know what is the reason for this, because we use indexing in R and Python all the time. I thought that maybe SQL table can change because it is a snapshot for a business state at this moment.
So I would say that like what I'm used to seeing as an index in Python data frames, pandas data frames, you can think of that as the primary key. Okay, so it's sort of a unique ID. But at the end of the day, the database still gets to decide how it wants to pull, the information for you. And you can specify the primary key. I can say I want customer 1, 2, 3, 4, 5, but you don't have to. You can just say I want all the customers who live in New Jersey, and the database will do that for you.
Okay. Can table change between queries?
In terms of like people adding and removing data,
Yes.
yes. So that's gets into sort of a tricky issue if you have a lot of users and a lot of activity. So for example, if you have a lot of activity on your bank balance and you just say, hey, tell me, my bank balance, right? Then it's possible that the value is changing very quickly because there's whole lots of transactions. And so then that gets into some very tricky issues around consistency and stuff. But generally speaking, you're gonna have an answer that was correct for the time that the query ran, but since then, other things might have hit the database, and so maybe there's been additional transactions, and now you have a slightly different amount in your bank account.
Can table change just because it is resaved on other server, for example? Can it column shuffle, row shuffle? Can it happen?
So in relational databases, we typically think about these as being very static, sluggish, schema-first databases. So when I say I have a customers table and I say there's 5 columns in it, it's customer ID, first name, last name, whatever, phone number, email address, that's it. Now, it doesn't mean that you can't ever change it. You can actually, run commands to change it. But generally speaking, that is going to be an exceedingly rare event. Okay. And one of the reasons why is you're going to tend to break all of your code when you do that. So the expectation is that, generally speaking, the schema does not change. Okay.
No, not schema. I mean that the information is still the same, but can be columns be permuted? Because when you do a query, for you it doesn't matter. You take the names of the column. But what if can they be permuted without our knowledge?
So I haven't used all the database systems out there. I will answer you this way. In theory, the order of the columns does not matter. Okay. And you can ask for your data to be returned with the columns in whatever order you want. Okay. You can rearrange them. Because we're trying to think of this in terms of like set theory, like give me all the rows that match this and I want these columns, order doesn't really matter. The reality is every relational system I know stores columns in a particular order, and they will by default always return them in that same order. But I don't think the order of the columns ever will change the results you would get for a particular query. Okay, if that helps. All right, cool. Thanks for the questions. All right, so popping back here. So I've pretty much covered chapter 1 of the book. In addition to this, there's an appendix A that talks about this sample data that the author has created. And so I was just showing there's scripts for different systems. So whatever system you guys want to use, that's fine. If you have access to something at work, access to something at school, go ahead and use that. If you want to install something yourself, fine. I'm just going to give you one example. If you don't have a particular preference, if you are somebody who's already using Jupyter notebooks for machine learning stuff, you can access a SQLite database very easily from Python. So let me just jump over here. And I'm just going to click on this Jupyter notebook So you can go ahead and you can download your own copy of this. And basically you're going to see I'm going to use two packages. I'm going to use the SQLite 3 package for talking to the SQLite database, and I'm going to use pandas just because it has pretty data frames. Okay, we're going to create a connection, and here you specify the name of the file. So the author created a file called teach yourself SQL, TYSQL.SQLite. File can be named anything. The thing that's really nice about SQLite is everything's just in one little file, the whole database. And so pandas has this read SQL query command. And so we haven't yet gotten into, but if I write this command, select star from customers, then basically it will run this query, put it into my data frame DF. And so if I print my data frame, then you can see here's my nice pretty thing with 6 rows, and I'm not quite sure about 10 columns. All right. So if you download this TYSQL SQLite file and you grab a copy of this Jupyter notebook, then if you want, you can use this to do all of the programming examples in the book. You just have to change this query right here, and you can run whatever you want against that. So again, feel free to use whatever database system you have access to. You can create those tables and you can create the data, but this is just one way for those of you who don't have a preference, if this is easy enough for you. And then also just wanted to show you, since you may at some point want to access data from, you know, a notebook that's doing something else. And so this is the little handful of whatever, 3-4 lines of code that you need in order to pull stuff out. All right. So that's what I got for today. Any other questions, comments, thoughts? All right. So I'm going to wrap up the formal part here, as I said. So Ryan is recording this, and so I'll ask him to post it to his YouTube, and I'll add the link to that video to our repo here. And then next week, so same time, so 5:30 California time next week, James will cover the first 2 meet chapters. So we're gonna actually get into retrieving data and then also sorting the data that you're retrieving.
Thanks, Ted. I'll
Yeah.
end the recording right here.